Hello, welcome back to the Google IT certification course. Today we will discuss about various topics related to subnet mask and the IP address classes, their ranges, and also about protocol like address resolution protocol. So, in the last session we just touched upon the concept of subnet mask. Subnet mask identifies the network portion and the host portion. The network portion value will be as represented as 1s and host portion will be represented as 0s. And it is very important to differentiate between the network portion and the host portion of an IP address. And we have discussed about the three different classes of IP addresses which we use in our day-to-day usage. So, the class A has the very first octet as network and the remaining 3 octets as hosts, and class B has network, network and host, host, and whereas class C has network, network, network and host. Now, by substituting these values in the formula, we can see that this is the subnet mask for each class. So, you can see here class A, and this is the format of class A. The first octet happens to be network and then the second, third, fourth octet happens to be host. So, wherever there is n bit or n bits network bits, so we have 8 bits set to 1s and the remaining 3 host octet values are set to 0. So, this is the default subnet mask, and when we convert this in the decimal format from the binary format, we get the value 255.0.0.0. This is the default subnet mask, and since there are 8 bits used as a network portion, we also can represent the subnet mask in a slash notation called /8 for class A. So, in short, if we have to represent an IP address in class A including the network portion, we represent it as 10.0.0.0/8. So, this represents it is a default class A network. And in the similar lines, when we substitute value 1 for these network octets and 0 for these host octets, we get this value 255.255.0.0. So, this is the default subnet mask for class B, and in the slash notation it is represented as /16. So, if we consider a class B network, let us say 172.16.0.0/16. So, this is an example of class B and it is represented with /16. So, in the last class we have for usage in the networks is class C, and we have n.n.n.h. So, we have 255.255.255.0, which is the default subnet mask, and it is 8 plus 8 plus 8 is 24. So, /24 is the default mask for class C network. Let us suppose we have 192.168.1.0/24. So, this is a class C network and the default subnet mask. So, this is very important for an IP address. When we assign an IP address to a computer or any network device, most times the subnet mask is automatically assigned. So, subnet mask plays a very important role in the network communication. Maybe in the future session we will learn about the concept of subnetting, where this default subnet mask will be further divided into smaller networks, and that is distributed to various organizations by concept of subnetting. Okay. So, next we have the class A. We only took the range, but how did we get that range, and how many networks are available in class A, and what are the number of hosts available for each of this class A network? We substitute the network bits and host bits into the corresponding formula to calculate the total number of class A networks. The formula is 2 to the power of number of network bits and minus priority bit. So, the priority bit we have used for class A is 1 bit. The value is 0, but only 1 bit was used. So 2 to the power of 8 minus 1 is 2 to the power of 7, and the value of 2 to the power of 7 is 128. And this 128 networks, we have network 0.0.0 and 127.0.0 as reserved networks, and they are not valid. We have seen in the last session, they cannot be used. So effectively there are only 126 networks available in class A. 126 different networks in class A. But each network in the class A, how many hosts or how many IPs are possible? So we have 24 host bits. So the value is 2 to the power of 24 minus 2. And why we have to subtract minus 2 is because one of them is network ID and the other one is broadcast ID. So yesterday's session, the last session, we have discussed about the network ID, broadcast ID and valid IP address. So network ID and broadcast ID are those which we cannot use for the hosts. So we have effectively 1,67,77,214 IP addresses or hosts available for each class A network. In short, we represent this as 16 million IP addresses. So in each of the class A network, there are 16 million IP addresses. This is the scope for a class A network, and hence it is recommended to use for large networks. And when we substitute the same formulas for class B and class C, we get to know the range of the number of class B networks, and in each class B network how many hosts are possible. And let's have a look at the class B network now. So in the class B, substituting these values accordingly, we have 16,384 class B networks, and in each class B network we have 65,534 hosts. This is the class B values. So this is used for medium sized organizations. Class A is used for large organizations, class B is for medium sized organizations. And then finally we have class C, and in class C we have close to 2 million networks, and in each network we have only 254 IP addresses, and hence this is used in small networks. Small organization networks use class C. So this is the scope and range for the class A, B and C networks. So we also discussed earlier about the IP addresses and the network addresses. So the range of addresses that are reserved for private, the IP version 4 addresses are divided into two categories called public IP addresses and private IP addresses. And these private IP addresses are reserved, meaning they cannot be used on internet. They are used within the organizations. They are used within the networks, within the organizations. They are not meant for internet usage because these IP addresses are not valid. The private IP addresses are not valid or not routable on internet. And these IP addresses are free for anyone to use. Any organization, any individual, any college, university can make use of these IP addresses as per their requirement. And we can see these are the reserved IP addresses for private use. And you might have observed in your computer labs, majority of the labs use these private IP addresses because these are free to use and anybody can use these IP addresses. This is 24 here, 24/24. Just now we have learned for class A the mask is /8, for class B the mask is /16, and for class C it is 24. So it's 24/24 means default class C network. So now we have seen that the private IP addresses, and they are free for any organization to use, and majority of organizations within their computer networks, they use private IP addresses. But remember, if you want to use internet, you want to access internet, we must have a public IP addresses. Without public IP address, we cannot access internet. So other than these IP addresses that we have mentioned in the private IP addresses, other than these, the rest of them are all public IP addresses. So let's see the public IP addresses in use, and this is the list of public IP address in each class, and these public IP addresses are assigned by the internet service provider. Internet service provider. In the last session, we did quick review of how the IPs were allocated. So, the global IP addresses are managed by an organization called Internet Assigned Numbers Authority, INA, and under INA we have regional internet registries, and under internet registries we have ISPs, and these provide IP addresses to the end users and organizations, and it is mandatory to have public IP address to access internet. So, by excluding those private IP addresses, the rest of them are all public IP addresses. So, we can see by excluding 10, the rest of them are all belonging to public range of IP addresses. So, this is the scope for each class and the public IP addresses allocated by the ISPs. So, having known about the private and public IP addresses, it is important not to use public IP addresses in our networks. We have to ensure that we use only private IP addresses in the network. In the later session, we will learn about how to convert these private IP addresses into public IP addresses with the help of a function called network address translation. Today, the internet is so vast that millions of users are accessing internet, and we do not have that many number of public IP addresses. So, in order to save those public IP addresses, the concept of network address translation was introduced, wherein the private IP address in the local LAN will be converted into public IP address assigned by the ISP. Let us suppose in your college, in your computer lab, if you are able to get internet, you must observe your local computer will have a private IP address, but you will still be able to access internet. But according to the rule, with private IP address, we cannot access internet. But how do we get this? Because of the solution called network address translation. Because of the shortage of public IP addresses, ISPs will allocate one public IP address for the whole organization network, and the router, on the router we will configure the concept called network address translation, and that will translate the private IP address to public IP address and vice versa. So, it is important to know that to access internet we must have public IP address, and without a public IP address we will not be able to access internet. But because the private IP addresses are free, n number of users can use these private IP addresses. But having a private IP address, also people would want to access internet, for which we have the solution called network address translation. So, I am going to show you a quick example of an application through which we can build networks. A small network we can build and just assign the IP addresses and check the communication. After which we go to the next topic called address resolution protocol. Okay. So, this is an application which is free, and anybody can download this application from the internet from the website called netacad.com. So, this is the application. The name of this application is Cisco Packet Tracer. I repeat, the name of this application is Cisco Packet Tracer. So, using this application we can build small networks and enable communication between these networks. So, it is a very simple application to use. We can create small local area networks, we can create wide area networks, we can also create complex networks in this application by the help of switches, computers, servers, routers. So, we can use all these network devices, even the cables that we have discussed in the earlier sessions, the straight cable, the crossover cable, all these can be used in this application. So, let us look at this application and how to build a small network. Okay. So, let us see the application usage. On the bottom left hand corner, we have these various objects called routers on the left hand side, and next to that we have switches. You can see these are the various switches available, and the third and fourth object we will not be using. The fifth object, if you click, then we get the cables, different types of cables here. The straight cable, the crossover cable we will be using now, and then on the second line on the left hand side we have end devices, which are computers, laptops, servers, etc. So, what we are going to do now is take few computers. So, to select the computer we have to click on this object. So, click once and then you can see an orange color circle appearing there. So you just click on the open space, the computer appears here. So similarly, we can create few computers, at least 2 or 3 required to set up a small local area network. And then to establish data communication between these computers, we would require a switch. So on the first line, we have this second object called switches. We can select the first switch. We just click on the switch and take it to this open space, and we have the switch and the computers available. Next, we require the cables to connect between the switches, switch and the computers. So we have to select a straight through cable. The third object is a straight through cable. So we have to select this cable and then click on the computer once. It will display the ports available on the computer. So we have to connect this cable to the fast Ethernet port on the computer. Once we click that, then we have to point this to the switch. Once we click on the switch will display the various ports available on the switch. Now you can see this is a 24 port switch and there are 24 ports available. We can connect this PC on any port on this switch. So you can see a link has been established between the computer and the switch. And similarly, we have to select the same straight through cable and click on the second computer, select the port fast Ethernet, and then click on the switch and select the second port, and similarly select the cable, connect the computer and the switch. So this is how we can set up a simple local area network. So we also have an option to enhance the size of the objects by just clicking this plus sign. So you can make this network look bigger. So this is a simple local area network. This is a simple local area network, LAN. Okay, so this is a simple LAN, and we have connections available between these computers. So we need to assign IP addresses. But just before we assign IP addresses and enable communication between them, let's question ourselves that we assign an IP address to this computer as well as this computer and this computer. And let's suppose we are going to assign IP address like 192.168.1.1 for this computer. So let's assign. So you just have to click on this computer, a pop-up window will appear. In this, you have to choose the desktop tab. You can see the third tab here. Click on this desktop tab and new options appear here. And you have to click on this first object called IP configuration. And it is in this object that we are going to assign the IP address to the computer. So just click on this object and you get another window to assign the IP address. So you have two options. One is static IP address assignment and the other one is the DHCP option. So we will choose the static IP because we are going to configure the IP address manually to this computer, and the IP address is going to be 192.168.1.10, let us suppose. This is the IP address. And in the subnet mask field, you just click here, automatically the corresponding subnet mask would appear. So IP address and subnet mask are essential for the LAN communication. This default gateway is required when you want to communicate with a computer in another network. So for now, we just want to give the IP address and subnet mask, and we just have to press this X button here. We just have to press the X button here and it closes. Then we have to go to this fourth option called command prompt, or you can see the run here. Just click on this, we get the command prompt of this particular PC. We get a command prompt of this particular PC. So we want to check what the IP address was assigned to this computer with the command ipconfig, one single word, ipconfig, and you can see the IP address that was allocated to this computer, 192.168.1.10, and this is the default subnet mask. Similarly, we have to assign IP address to the second and third computers as well, and then want to check communication from computer 1 to computer 2. So from computer 1, we will know the IP address of computer 2 and we can communicate. But in reality, for computer 1 to actually communicate with computer 2, how does computer 1 know whether computer 2 or computer 3 has the IP address of 192.168.1.20? So, your computer has an IP address, but how does it know this IP address is available to this particular computer? He will not know. So, just having the IP address alone is not enough for communication in the network. You must have both IP address as well as MAC address to communicate with each other. So, we have the next protocol to discuss called Address Resolution Protocol. This address resolution protocol is very important for the actual data communication. So, this is basically providing a matching between the MAC address and the corresponding IP address. So, this computer has this IP address and that is mapped with this particular MAC address. So, this is a very important protocol in the LAN communication. Without the ARP, the two computers in the LAN will not be able to communicate with each other. So, this has two different types of messages. The ARP protocol uses two different types of messages called ARP broadcast message and ARP reply message. These are the two messages internal to this ARP protocol. So, the ARP broadcast is sent as a broadcast to all the computers or devices in the network in the LAN, and then only the device to which the IP address will match will process the request and send a reply message, whereas all other devices which have received this broadcast will discard this message. So, the ARP reply is the message that comes from the corresponding PC back to the sender saying that this is my MAC address. So, according to this picture which we have just created in the network, computer A is given an IP address of 192.168.1.10 and computer 2 we have not yet assigned the IP address. At this point of time, if you verify the ARP table on this computer, there is a table called ARP table and we can verify using the command ARP space -A. When you look at, there are no entries at this point of time because our computer 1 did not send or receive any data to the second or third computer. So, there are no entries. So, the ARP table will be empty initially. Only when there is a communication, the ARP entries will be built. So, let us look at the ARP table information. What does an ARP table contain? The switch maintains a MAC address table. We have seen this in the previous session, how the switch builds the MAC address table. It will be empty by default and as and when the user send data, the entries will be filled in the MAC address table. The router will maintain the routing table. This we will see shortly in the next sessions. We will be watching the routing table output. Whereas these computers and servers, end devices, they maintain ARP table. And we have just observed in one of the computers, it was empty. But as and when you send and receive data, the ARP table will be built. So, the ARP table will contain IP address of the device and its corresponding MAC address, the IP address to which you communicate and its corresponding MAC address. And remember, this is available or applicable only for local area network communication. ARP protocol works only in the LAN, not on the WAN. It cannot cross the router. It is working within the network only, because router is a device which stops the broadcast and ARP is a protocol which works based on the broadcast. So, when a computer wants to know the MAC address of the neighbor computer, it will send a broadcast and it goes to all the devices in the network and the router will stop that broadcast. Router is a layer 3 device and layer 3 device has a capability to stop the broadcast. So, let us get back to find out the ARP table. So, you can have the ARP table on Windows operating system. We just have used this command ARP space -A is a command to verify the ARP table, and in Linux just the ARP command would do. So, we have an example of the ARP entries. You can see here, this is the command we have executed and this is the entries that we have at this point of time. But when we checked on the local computer here, there were no ARP entries because they were not learnt at all. And this information learnt is not permanent. There is a certain time interval after which these entries will be flushed away. And again, next time when you check the communication, the ARP table will be built. And the reason why I have not assigned the IP address to the second computer was so that we can check the communication and then the ARP table will be built. So now to verify this ARP, we are going to assign the IP address to the second computer and then check communication from computer 1 to computer 2 and then verify the ARP table. So let's assign the IP address to the second computer. Go to desktop, go to IP configuration and then assign the IP address 192.168.1.20. We have assigned 192.168.1.10 for the first computer, and for the second computer we have assigned the IP address of 192.168.1.20. So we can verify the local computer's IP address with the command ipconfig, and we can see the IP address being assigned to this computer. And then also on the first computer we have assigned the IP address and we have also seen the ARP table. But now I want to ping from the local computer 1 to the computer 2 with this corresponding IP address. The local PC IP address is 192.168.1.10. The second computer IP address is 192.168.1.20. So when I generate the request from the local PC, you can see that there is communication. There is a reply for the ping command. We have got the reply for the ping command. And now if we verify the ARP table, previously when we checked the output, the ARP table did not have any information. But now we have established data communication, and let us verify the output of the ARP table with the command ARP space -a. So you can verify now the IP address of the destination computer and its corresponding MAC address. So this table was empty earlier, but now we are able to get information. In a similar way, I am now going to assign the IP address to the third computer. Observe here, click on the computer, go to desktop option, go to IP configuration option and then assign the IP address 192.168.1.30. Remember, within a local area network, every computer should have a unique IP address. This has to be manually assigned by the administrator. So next we go to the command prompt wherein we verify the IP config of this computer 192.168.1.30. So now we go back to the first computer. And ping 192.168.1.30. So this is the communication from the first computer to the third computer, and it is communicating. So now when we verify the output of the ARP table, we have two entries. This is the first computer, we have the IP address of the second computer and its corresponding MAC address, and that's the third computer IP address and it is the MAC address of the third computer. So ARP table contains the IP address of the device and its corresponding MAC address. Without knowing the MAC address of the computer, the PC cannot send or receive data. So this is the importance of the ARP table and its functionality. And it is all happen in the background. We don't use ARP manually. We are using the ping application or command. Ping is a command used for troubleshooting. Suppose there is a problem in the network, how do we troubleshoot? We use ping as one of the important command or utility. So with this we get to know whether that destination computer is reachable or not. Suppose at the same time if I try to give another command called ping 192.168.1.40, let us suppose, but I have not assigned this IP address to any computer. My computer does not know, so he is going to try, he is going to check, he is going to send the broadcast asking, hey, I am looking for the IP address called 192.168.1.40, but nobody responds. Suppose for example you are in the class and you call a person by name who is ABCD here in the classroom, nobody will raise the hand because that name does not belong to anybody. So similarly here, when we try to communicate with a computer IP which is not available, so this is the output we get, request timed out, when there is no computer available, or if the computer is available but it is turned off. If the computer is switched off, it will not be able to respond. So, we get a message called request timed out. So, in network communication, if there is communication between the source and the destination, we get a reply like this, which has information of, see, we are trying to communicate with the IP address, we get reply from the same IP address, and the number of bytes of data that was sent in the packet, and the amount of time the packet has taken to go and come back. This is the time interval taken to the packet to go and come back. And TTL stands for time to live, though the name is time to live, is not related with a time object or time in sense. So, TTL is actually hops. The maximum number of hops in TTL is 255. So, from the source to the destination, every time the packet is crossing the network, the router will decrement the value by 1, and the final destination value cannot be less than 1. In case if the value goes less than 1, which is like happens to be 0, which means the destination is not reachable, and the computer or the router will display a message that time exceeded, cannot reach this particular destination. So, ping helps us to know the communication between the source and destination. So, in this session we have so far discussed about the subnet mask, the default subnet mask, how it is represented in the traditional notation, that is 255.0.0.0 for class A, 255.255.0.0 for class B, 255.255.255.0 for class C, and its corresponding slash notation, that is /8 for class A, /16 for class B, /24 for class C. And then we have discussed about the options of the allocation of the IP address and checking the communication. And now we have the topic called IPv6. The next discussion is about IPv6. IPv4 is very widely used, commonly used everywhere, but IPv6 was introduced in the year 2000, but the usage wise is very slow. So, IPv6, we have already mentioned earlier session that it is there to overcome the limitations of IP version 4, because IP version 4 addresses are finished, they are no longer available. All the IPs which are available have been allocated to organizations, individuals, etc., ISPs, etc. So, we have to use IPv6 now. The future is going to be about IPv6 for network communication. So, this IPv6 address has 128 bits, and this is represented in hexadecimal notation, whereas IPv4 addresses are represented in decimal notation, IPv6 addresses are represented in hexadecimal notation. So, we can look at here the IPv6 address. When converted into hexadecimal form, there will be 32 hexadecimal values, and this is the representation of an IPv6 address, full length IPv6 address, where here x represents one hexadecimal number, and there will be 8 quadrants: quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4, 5, 6, 7 and 8. So, 8 quadrants, each of them are 4 hexadecimal values. When you multiply 8 into 4, you get 32 hexadecimal bits. And also there is a representation that one hexadecimal bit equals to 4 binary bits. One hexadecimal bit equals to 4 binary bits. And now we have 32 hexadecimal bits. So, 32 hexadecimal into 4, we get 128 bits, which is the actual length of the IPv6 address. So, an example of IPv6 address is represented here for your understanding, that is 2001:000:000:C15C:00:00:000:009C41300. So, you can see how long or how lengthy this IP address is when compared with an IPv4 address. Traditionally, IPv4 addresses we have seen 10.0.0.1 or let us say 192.168.1.10. So shows small when compared with the IPv6 address. And since it's hexadecimal values, the values here, they are not case sensitive. These IPv6 addresses are not case sensitive. So, there are rules available in IPv6. We can make this IPv6 address look smaller by using these rules. So, when there are zeros in the beginning, we can substitute them with 0, we can omit them basically, the zeros can be omitted. This is rule number 1. So, we had in the second quadrant 4 zeros, they have become one single 0. So, that is one advantage of IPv6, reducing the size of the IPv6 address. If you have 4 consecutive zeros in one quadrant, we can substitute with one single 0, and if you have multiple quadrants successively with zeros, we can represent with just a double colon. So, by applying these two rules on the previous page IPv6 address, you can see it has become so short by applying those rules. Okay. And another benefits of IPv6 is there are no classes, like in IPv4 we have class A, class B and class C. Here we do not have classes, and there is no broadcast in IPv6, has been removed. So, these are the advantages of IPv6. Apart from the length of the IPv6 address, there are billions of IPv6 addresses which are not available in IPv4. And some of the IPv6 addresses you can see here: global unicast addresses. This is similar to public IP addresses of IPv4 used on internet. IPv6 public IP address starts from the IP address 2000. And if an IPv6 address starts from FC00, this is called as private IP address. It's called as private IP address. This is link local address, or also called as automatic IP address. This is automatically assigned by the computer. And loopback, this is loopback, similar to in IPv4 127 series IP address we have. This is IPv6 loopback, and this is also called as default. This is called as default IPv6 address. This is a loopback address similar to 127 series in IP version 4. I can show you quickly on the computer, on my local computer, a usage of IPv6 address, ping ::1, which is a loopback address. So, you can see we get a reply from the operating system, which means the local computer has IPv6 support available. And when we check IP config on the local computer, we can see the IPv6 address support available or not from this. So, we can see in the network properties, we go to the connections, and here, so you can see here from the properties IPv6. So, you have IPv6 here, it is not available, so you can just enable it. So, now when we come back after enabling IPv6 to the command prompt, you can see IPv6. You can see here the FE80, you can see here, this is IPv6 address. There is support available for the operating systems right from Windows XP, Service Pack 2 and 3 onwards. IPv6 is available. But operating system like Windows 7, Windows 8, Windows 10, Windows Server operating system, they all come with default support of IPv6. So, this is the discussion today, where we have learnt about the concept of a simple network, how to assign IP address in subnet mask, check the communication, and have the protocol ARP gather the information about the MAC address of the devices, and then check the actual communication as well as the IPv6 addresses. Okay. So, in the next session, we will be learning more about how the routers work, how to configure the routers, routing protocols, and check the communication with the practical sessions on the router. Okay. Thank you for watching this session.